going to look at a sample calculation. So our learning intention is to solve volumetric problems using the formula method and using first principles. So in volumetric analysis, you'll always be asked to do a calculation on your titration. Usually they ask you to express concentration in moles per litre, grams per litre, or parts per million. There's two methods to do this. There's the formula method and the first principle method. Now the formula method has not worked since 2016, and as a result we're going to focus on the first principles method. So I'll briefly show you the formula and do it very quickly, but we'll spend more time on first principles, and all videos on this topic will focus on the first principle method as it works all the time. So here's our question. It says 25 centimetres cubed of a 0.1 molar sodium carbonate solution was titrated against a solution of hydrochloric acid using methyl orange as an indicator. The average titration figure was 26.65 centimetres cubed, and there's the equation for the reaction. Then it says calculate the concentration of the hydrochloric acid in moles per litre and in grams per litre. So we're going to just look at the formula method very quickly. The formula is MA by VA over NA equals MB VB over NB. So A stands for acid and B stands for base. So MA is the molarity of the acid, and that's what we're trying to find. So that's given X. The volume of the acid, you can see here in the question it says that the average titration figure was 26.65. So that's what the volume of your acid is, 26.65, and N stands for the number of moles from the balanced equation, which we can see here is 2. If we do the same thing now for the base, the molarity of the base is 0.1 moles from the question. We can see that the volume of the base is 25 centimetres cubed, and the number of moles from the balanced equation is 1. So if we fill that in, we get X by 26.65 divided by 2 is equal to 0.1 by 25 over 1. So that's just filling into this formula here. Now you want to get X on its own, so you need to rearrange. So that would be 0.1 by 25 over 1, and that's multiplied by 2 over 26.65, and I've gotten that from multiplying both sides by 2 and dividing both sides by 26.65, and you get an answer of 0.19. So that's 0.19 moles per litre. So now you want to get that concentration in grams per litre, and so that was part A. So if we do part B down here, we know that to go from moles to grams, you must multiply by the molecular mass. So because this is the acid that we're looking at, you need to find the molecular mass of HCl, and that's equal to 36.5. So you simply do your 0.19 multiplied by 36.5, and you get 6.95 grams per litre. Now, this method is quick and it is easy, but the formula method hasn't worked really in titration since 2016. So we're going to look at the first principles method next, and it's a lot more reliable, and I strongly recommend that you avoid the formula and use first principles only. So for first principles, there's 3 steps. The first thing is you need to find the moles of your standard solution in your titration volume, and you use this formula here. The second step is to find the moles of your unknown solution in your titration volume, and you use your balanced equation for that. And the last step is to find the molarity of the unknown solution using this formula here. So there's 2 formulas and a balanced equation to be used. It's 3 simple steps and it works every time. So let's try it for this question. So here we have the same question that we done using the formula method, so let's try it now with first principles. So step 1 is to find the moles of your standard solution in your titra volume. So our standard solution is Na2CO3, it's the sodium carbonate, and we use 25 centimetres cubed of it. Now, we know that we have 0.1 moles of it in a litre. So we simply fill into our formula, which is moles per litre divided by 1000 and multiplied by the titra volume that we use. So we know the moles per litre is 0.1 molar. The titra volume that we use is 25 centimetres cubed, and we've to divide that by 1000. So what we get is 0.0025 moles. And that's step 1 complete. So step 2 involves looking at your balanced equation. So our balanced equation is Na2CO3 plus 2HCl goes to 2NaCl plus your H2O and your CO2. So if we look, this is a 1:2 ratio. Now, we don't have 1 mole of our Na2CO3. What we have is 0.0025 moles. So instead of 1 mole, you'll fill in your 0.0025 because that's the number of moles that's present in the titration. And because it's a 1:2 ratio, it means that for every 1 Na2CO3 we've 2 HCl's. So for every 0.0025 moles of Na2CO3, I must have 0.005 moles of the HCl, and that's coming from our 1:2 ratio. I have twice the amount of HCl as I do Na2CO3. Now this asks for the moles of the unknown in the titra volume. The number of moles of hydrochloric acid is 0.005, so that is the moles of our unknown in our titra volume. So the last step is step 3, and it asks you to find the molarity of your unknown solution. So we know that we have 0.005 moles, and that's in 26.65 centimetres cubed now, because we're dealing with the HCl. I know that I have 0.05 moles of the HCl, and I know that that's in 26.65 centimetres cubed, because that's my average titration figure from my question. So to find out how many moles there is in a litre, I must use the formula in step 3 on the last slide, which is the moles in your titra volume multiplied by 1000 divided by the titra volume. So that's 0.005, multiply that by 1000 and divide it by 26.65, and that gives you an answer of 0.19 moles per litre. So it's key that you do these 3 steps individually. Step 1 is linked with finding the moles of your standard solution in your titration volume, or in the volume of it that you will use, which is 25 centimetres cubed. The second part is to find the moles in your titration volume of your unknown, which is our acid here. So I calculated that it was 0.05 moles in 26.65 centimetres cubed. And step 3 then is to find the moles of your unknown in moles per litre. So that's done using this formula here. The last thing then we want to do is we want to find it in grams per litre. So to go from moles to grams, you have to multiply by the molecular mass. So to find the molecular mass, we're looking at hydrochloric acid. So the molecular mass of hydrochloric acid is 1 plus 35.5, which is equal to 36. And what we are going to do then is you're going to do your 0.19 multiplied by the 36, and you get 6.95 grams. So that is your answer to part B, and this is your answer to part A with all the steps involved. So I'd strongly recommend that you go over this calculation again, get used to the first principles method, because as I've said earlier in the video, it is the only method that has worked since 2016. That's it for this video. Have a read through the learning intention to make sure you understand